Lucas Kyle shows that he knows stuff about the solar system. I think he knows too much.
I wanted to know about the lights in the night sky.
They move.
We move. What do you think that means?
I think we live on a ball.
On a
and
ball.
It rotates, giving the impression that the lights move, but they don't. It's the same with the sun. It doesn't move. We do. We spin, and that gives us day and then night.
You mean he knows too much? You mean like a conspiracy, or you mean like he just knows too much given what he should be able to know?
So Lucas Kyle is born and raised in the silo. So all he knows is this tube, and he sees a feed in the cafeteria from the cafeteria camera, and he sees these lights in the upper strip, and those lights are stars. And from that feed, he's able to determine that he lives on a ball, and the ball is rotating, and the ball is going. He's saying the sun is stationary. Somehow implies that the Earth is going around the sun, and he's drawing all these conclusions from that strip of the feed.
Oh,
like
I mean scientifically. You mean
Yeah,
scientifically, he has come to conclusions that he should not have been able to.
Right. So he's right. Well, we know he's right because we have satellites and rockets, and we've had thousands of years of science to build on and evidence. But he has none of that.
That's right.
So
I had the same idea.
I found it unrealistic that he wouldn't get anything wrong. Right.
Right.
Can
we also appreciate? Okay, it would have been super cool because he has this limited information. He only has the views of the outside world from whatever he sees from the cafeteria, few twinkling lights. How cool would it have been if he had taken that data, that's the only data he has, and come to some wrong conclusions?
I think that would have been better. That would have been really cool.
Fantastic sci-fi.
Because he would draw the conclusions that he knows he can, he would draw conclusions from the feed that are realistic to draw, and then he would probably go too far and speculate too much, but those would be wrong in some way.
I mean, it would be entirely reasonable for everyone in the silo to be flat earthers. Because they don't have the data that suggests that it's a round planet.
In fact, now that I'm thinking about it, even just coming up with the idea of a flat Earth might even be a leap for people because they've never really seen the surface of the Earth. They've never looked out to the horizon. So do they even have a conception of what a big flat thing is? Like that, going from the world is a cylinder to the world is flat would be like generational change step one. And then going from flat Earth to round would be like, what the hell's going on? And this would probably take generations because it took us with the full sky, us as humanity, to come up with the conclusions itself.
I looked this up. I said, what information would he have needed to have in order to figure out that we're on a round planet? So I looked it up. It was Aristotle. Aristotle got this somewhere in the 350s BC. That's when he was lived, but I don't know how old he was when he figured this out. And what he did was during the lunar eclipse. So when when the moon is passing behind the Earth.
Right. So this is the Earth's shadow, and the moon is inside the Earth's shadow.
Exactly. And when that eclipse is starting or ending, so it's definitely the shadow of the Earth that's being projected on the moon. It's round. So here's an eclipse sequence. Yeah, please walk us through it.
Okay, yeah. So this is before the eclipse. You get a full moon, and then as the moon moves into the shadow of the Earth, this would be the shadowy portion.
And to be clear, the moon is going right to left, right?
Right to left. So the moon,
it's going into the shadow. Okay, perfect.
Right, yeah. So it's going right to left, and as an hour passes, you get the shadow of the Earth. Notice the
curvature right on that Terminator line, that shadow to the light. Clear. It's a shadow of a round object, and if it's us causing the shadow, round planet.
And then as the moon sits in the Earth's shadow, it looks red to our eyes. That's just there's some atmospheric stuff for the reasons for that. And then it leaves the Earth's shadow. It's a round shadow line again, and then it comes out. So this guy, we found this Pixel Brew. Found this cool picture. You can see
very nice.
This is the Earth's shadow, and this is the sunlit portion. Clearly a curved shadow.
So unless Lucas Kyle has these can see eclipses, which I don't think he can because it's recycled feed, there would be no reason for him to think that the Earth is round. He didn't have this data.
Right.
I mean, I guess I should say, other people before Aristotle thought the planet might be round, but this was the data. This is the experiment that's like nail in the coffin. Definitely is.
Right. And it's ultra confusing because we see straight lines like this on the moon all the time, which is due to the relative position of the sun, Earth, and the moon. So we only see the lit portion and the other portion is in shadow. So you get a straight line then.
So this is purely a geometric factor of where the moon is relative to the Earth and where the sun is, and then where we are on the Earth looking at it. So can we walk through this picture a little bit slower? There's the Earth in the middle.
Yep.
There's the sunlight coming from the right to the left.
From the right. Yep.
And then there's this dotted line with the circles. Like this is where the moon is. That's the orbit of the moon.
Yep.
And then there's the larger ring of circles.
Yep.
And this is what the moon looks like from the perspective of Earth. So if you are, let's look at first quarter.
First quarter, where
at the top,
up here. Yep.
Right. So note that the moon is half illuminated, but from
Yep.
Earth's perspective, if you're standing there looking up, you see lit up on the right, you see dark on the left, and that's first quarter.
Yeah. So and then last quarter, it's opposite.
Right.
Where it's still the same situation. It's just so it's like this. This is the sun facing side over here.
Exactly.
And this is the night side of the moon. And we see this nice straight line.
And that's exactly at the quarters, but other times you can get these crescents, so you can get these gibbous moons. Can we look down to the left?
Yep.
Exactly right. But still half the moon is lit up. We just happen to be on a slightly behind angle, so we see mostly shadow.
So Lukas Kyle is seeing these. He's probably seeing these moon cycles pretty often because it happens monthly, and then he has to discern. Oh, that's the moon cycle for the geometry between sun, earth, and moon. And then there's this. Every once in a while, there's a different situation, where I see a curved shadow that's due to the Earth's shadow, and from that I can draw the conclusion that the Earth is round. That's a huge leap.
I don't think he could have got that.
Right, because even just being like, there's a cycle to the moon, and the moon and this has this cycle to it, would be a huge leap, because he has no conception of what a moon, what the sky, what's Earth. Like, it would be incredible just to get to this point, and he's going beyond that.
I don't know which way that the camera at the top of the silo is looking. Like he doesn't have the full access to the 2 pi above us.
That's right.
He only has access of whatever that camera is looking at.
Right. And then to get to this is the next experiment
to actually measure the size of the Earth, and and it also shows that it's round. This is Eratosthenes.
So let's take a look at this picture here. So he was like in Egypt.
Yeah.
And there was a well in this place, Siene. And he saw that I think it was at the equinox, or no, at the solstice, the summer solstice. He saw at a well at this place, the sun rays came directly down, hit the bottom of the well. So he's like, okay, the sun is directly overhead at this point in the day at the solstice.
Because otherwise it wouldn't make it all the way to the bottom. It'd hit along the wall somewhere. Okay.
Right. And then he goes at the same time of year, but probably the next year, he's in Alexandria, and he sees that the sun rays are not perfectly vertical, and he sees this angle between, say, a vertical pole and a shadow. So he can measure the angle.
Yeah.
And he concluded that the reason why there's a difference between the rays angle is because I'm on a different part of the surface of the Earth relative to the sun. And from that angle, he could figure out the radius of the Earth. There's some geometry and trigonometry involved. But essentially, the difference in angle of the parallel sun rays allowed him to get an estimate for the size of the Earth. Actually, it's decently accurate.
Right. So this is a confirmation that an actual measurement of the radius, or I guess the circleness of the Earth. Right? And so no way does Lukas Kyle have this information.
No way. And keep in mind, like, this is Aristotle's in mid 300 BC, and this is like mid 200 BC. So we're looking at 100-year difference between it's round to I know how big it is.
I know
like,
how round it is. Right.
Yeah. And then in addition, we have to have the sun go around the Earth while rotating.
The other way. have the Earth go around the sun. You said it backwards. Yeah, you said it backwards.
Oh yeah, so sun and then Earth.
Yeah.
Right.
I don't think he has the information for this.
Right.
Because so the experiment so first of all, the heliocentric model was Nicholas Copernicus in 1543. Okay, and then in 1610, what is that? 60 something years, 60.
Yep.
70 something years. And this was the experiment. This was the measurement that says no, we really are in a heliocentric grid. So there was the Venus epicycle idea where you could look up and see Venus, and you see that it's different amount of light on it, so different crescent in all these pictures.
Yeah.
But when you really look at Venus, you see that it's sometimes gibbous, sometimes crescent, sometimes half, sometimes full. Yeah. And so I don't think Lukas Kyle could have seen this.
No way.
Especially because Venus. Okay, so the experiment shows that Venus needs to be also going around the sun.
Yeah.
And so if Venus had this epicycle where it was in between the Earth and the sun, but not going around the sun, these are the shadows that you see. This is your perspective you'd see. You would never see the fully lit up side because it would never be on the far side of the sun and therefore reflect light towards us. But what Galileo did is he saw that sometimes Venus would be, I guess, this big gibbous. Can we circle? Yeah, exactly. Which means that the light must be going from the sun to Venus, then bouncing off the Earth.
Right.
Which means that the sun must be in the middle.
Right.
Which means if the sun's in the middle of Venus, we're probably also Earth, and the sun's also going around the sun. Okay, now the thing that's really challenging about this experiment is that because Venus is closer to the sun than the Earth, that means we can't see Venus at night. We're just looking in the wrong direction. So you can only see Venus right at dusk and at dawn, right in this twilight hour where the sun is now below the horizon, but Venus is not quite yet. And so unless Lukas Kyle's got a telescope at that time of the day, like just lined up at the right, where Venus is in the right spot, his camera's looking at the right spot, the sun just went down. Like, I don't think Lukas Kyle has this information.
Right, because if the camera happens to be facing east or west, meaning, and it's not cloudy, so he could actually see Venus. First time, you got to be able to see it at dawn or dusk. You got to have the resolution on the screen to be able to discern the different, like, oh, it's a crescent, or it's a gibbous. When the sun is potentially blinding you at different points, and you got to be able to discern these subtle differences. No way at that camera.
Think it's got it.
No way. And in addition, this was Galileo saying, like, the sun is at the center of the solar system, but there were additional proofs.
There are three other proofs, experimental proofs.
Right. James Bradley, Friedrich Bessel, Leon Foucault, and I think maybe we should do these, go over these in our science channel.
I think, the actual discussion of this is going to be super long. Maybe we'll put it up on our science channel, SS Science. Yeah. Having a nice discussion about it.
So we go from Aristotle in 350 BC to Nicholas Copernicus in 1543 to more general proofs in the 1800s. We're talking 2,000 years of human thought and like going down the wrong path and thinking about it wrong and like getting to the point where I'm just like, okay, we're heliocentric. And he does it in like 10 years.
By himself. To be clear, Galileo did the experiment, but there were lots of other scientists at the same time and also a couple hundred years before that had the ideas in the water but didn't know how to prove it.
Right. And there was other people like Tycho Brahe and Kepler and Newton. We haven't even mentioned them. They were a big part of the story. And Lukas Kyle just
got himself.
There's no way. There is no way that he was able to draw those conclusions. So I think it would have been better if he drew a few good conclusions and then had wildly wrong ones because the camera feed is just insufficient to get all this information.
Wrong, but consistent with the data that he has available to him.
Yep. That would be cool.
That would be super cool.
And also in the same scene, we see Judge Meadows, Mary, explain like the actual situation with confidence. And we assume that she got that information from a book. So she knows because she read it in a book or in like an IT computer screen or something. But Lukas Kyle is not a higher up guy. So he doesn't have access to books or computers with that classified secret information.
Right. She like blew his mind and then said, F off. Like, what a super weird.
Yeah.
Also, good historians, they will be uncertain about the past. Even though it's the past, so it happened or it didn't happen. Is it written in a book or it wasn't written in a book? But even then, good historians will say, well, we don't really know what the historical context was. And we have this one person's opinion that they wrote down in the book. We don't really know what happened in the past. So Judge Meadows is talking real confident, but she also should not really know.
Right, she doesn't have that additional lived experience confirmation on the surface of the earth to be able to put that model that she's reading together. She's just kind of taken it all on faith.
Yup.
And trusting the founders, essentially. Yeah, that was fun.